Welcome all for the today's class. So today we continue with our epidemiology module, and today we are going to discuss about incidence, prevalence, relative risk, and odds ratio. And these are most frequently asked questions in the MRCG examination. Okay, so concentrate on this topic, and we are going to solve the SBS at the end, which will be on the line of our exam pattern. Okay, so the incidence, prevalence, relative risk, and odds ratio we are going to discuss. So in the epidemiology, basically we should know what is the core epidemiological framework. Okay, so there is a disease causation model. This model is very much fixed. Okay, so what exactly is a disease causation model? That there is a risk factor, there is an exposure to the risk factor. Okay, so that leads to the outcome. Okay, so there is an exposure, there is an outcome. Okay, so this is what is the disease causation model. Okay, so for example, smoking, that is the exposure to the smoking leads to the lung cancer. So smoking becomes exposure and lung cancer becomes the outcome. So this is the disease causation model. So there are certain terminologies we should know. What is exposure? Exposure is the related to the suspected risk factor like smoking. Then outcome is the disease or the event of interest. And example is a lung cancer. Then there may be exposed group. That means the group has got a risk factor, like we are dealing with group of smokers. Okay, then what is unexposed group? This group does not have the risk factor, for example non-smokers. Okay, and this is a very important 2 by 2 table which you have to understand very well. Okay, so for this session and the another session on the screen test, 2 by 2 table, please understand well. Okay, now in this 2 by 2 table, this disease is written at the top, while here on the side you have got the risk factor, whether the group is exposed or unexposed to the risk factor. While here these column mention whether there is a disease or whether the disease is not there. So diseased and the non-diseased column. Okay, and here exposure and unexposed population. Okay, so now in this 2 by 2, this particular format you have to remember the disease is always on the top and risk factor is always here on the side. Okay, when we deal with the screening test also, at that time disease will be the or the outcome will be on the top and the test will be on the side. Okay, so this please remember. So here this is the population which has developed the disease. So this is the population which has developed the disease. This is the population which does not develop the disease, and this is the whole population which is exposed, and this is the population which has not exposed to the risk factor. Okay, so this is the population, this plus this. Okay, so now let us see. A is the exposed population which is developed the disease, while B is the exposed population which does not develop the disease. So total exposed population becomes A plus B. Then this is the exposed population, this is the unexposed population which developed the disease, that is C, and this is the unexposed population which does not develop the disease, that is D. So total unexposed are C plus D. So total disease are A plus C and total non-disease are B plus D, and this all is the N. Okay, so A plus B plus C plus D is the N. Either this way or this way, if you calculate, this will be the total. So this particular 2 by 2 table you have to understand. So disease on the top and exposure is on the side. Okay, so most of the time the questions are asked on the calculations from this table. Okay, so now what are the different measurement scale? So different measurement scales in the data session we have seen, it may be nominal, ordinal, discrete, or continuous. Okay, so nominal like male, female, alive, dead. Okay, so here what we measure, we measure the proportion or the odds. So when you have this nominal scale and the data is like male, female, alive, dead, we will measure the proportion or the odds. Then if we have the scale, ordinal scale, like cancer stages 1, 2, 3, what we measure, median and the percentiles. Okay, if our data is a discrete in form of numbers, that is the number of seizure and section, we will calculate the mean and the rate. Okay, if our data is continuous data like blood pressure, weight, age, we'll measure the mean, standard deviation, and the rate. So these are the things which we are going to measure. Okay, so most of the epidemiological outcomes are converted into binary outcomes. Okay, for example, blood pressure. Blood pressure is a continuous variable, but that can be converted into categorical variable that is hypertension, which is present, yes or no. Okay, so here the continuous variable is converted into binary variable, okay, or the categorical variable, because we get the category either hypertension is yes or no. Okay, so why? Because it makes us the easier interpretation. This is clinically useful, okay, and easier for calculation of the risk. So converting continuous variable into the binary variable is useful and it is easier. Okay, now two important concepts we have to understand: proportion and the odds. Again, this is very important. You should understand these concepts: proportion versus odds. Okay, so first we'll talk about the proportion. What is proportion? Proportion is a part of the whole, either population or the whole sample or whatever it is. Okay, so we are talking about the part among the whole. Okay, so the range of the proportion is 0 to 1. For example, 300 females among the 800 participants. So we are talking about 300 females among the 800 participants. So 300 upon 800, that is equal to 0.375, equal to 37.5%. So this is what is the proportion. So interpretation is 37.5% of the participants are female. Okay, so this is what is called as proportion. So in proportion, we are talking about the particular part of the whole participants or the population or the sample. Okay, while in odds formula is part divided by non-part. Okay, so part divided by non-part, or odds equal to number with characteristics divided by number without the characteristics. Okay, so here the denominator is different. Here the denominator is a whole population, while here the denominator is different. Okay, so what is the range for the odds? Odds can range from 0 to infinity, while proportion can range from 0 to 1. Please remember this: range for the proportion is 0 to 1 because it is a ratio of these two. Okay, while here, though it is the ratio, but it is not, the denominator is not the part of the, or numerator is not the part of the denominator. Okay, so here the range is 0 to infinity. For example, 300 females and 500 males we are talking about. Okay, so that it will give you the odd as 300 versus 500. 300 upon 500 equal to 0.6. Okay, so interpretation is odds of being a female is 0.6. So in the whole population, if this is the scenario, the odds of being a female is 0.6, or the ratio is a 0.6 to 1. Okay, so this is what is the odds. Okay, so now, is there a relationship between the odds and the proportion? Yes. If you are given the odds, you can calculate the proportion. If you are given the proportion, you can calculate the odds. Okay, so sometimes they can ask you convert odds into proportion. So what is proportion? Proportion equal to odds upon 1 plus odds. Okay, so odds divided by 1 plus odd will give you the proportion. Now, how to convert proportion into odds? Odds equal to proportion upon 1 minus proportion. Okay, so when we are calculating the proportion, you have to do the plus in the denominator. When you are calculating the odds, you have to do the subtraction in the denominator. Okay, proportion equal to odds upon 1 plus odds. Odds equal to proportion upon 1 minus proportion. Okay, so that is the relationship between the odds and the proportion. Okay, suppose the odds is 0.4. Then find out the proportion. So proportion equal to odds upon 1 plus odds. So that is a 0.4 divided by 1 plus 0.4 equal to 0.286. That is 28.6%. Okay, so that is how the odds and the proportions are related. Now, next concept is a prevalence. Again, this is a very frequently asked concept, so please concentrate. So what does the proportion mean? So proportion measures the existing cases at a particular point in time. So it measures the existing cases at a particular point in time. So formula is prevalence equal to existing cases divided by total population which is examined. So prevalence is the total existing cases divided by the total population. Okay, so prevalence in percentage will be existing cases divided by the total population multiplied by 100. Suppose 200 women with PCOS are there among the 800 women which are examined. Then the prevalence will be 200 divided by 1000, that is equal to 0.2 or 20%. Okay, so that is how you calculate the prevalence. So prevalence is the total of the existing cases. So if your SBA is mentioning the words such as existing cases, current disease burden, or you are talking about the cross-sectional study. Cross-sectional study deals with the prevalence. Okay, point in the time, then snapshot. That means we are talking about the prevalence. So look for these words in the your stem of the question. That is, if the question is talking about or asking about the existing cases, that means we are dealing with the prevalence or current disease burden or cross-sectional study. Remember, cross-sectional study will give you the prevalence, okay, and it will never give you the incidence. Then point in time, snapshot, that means we are talking about the prevalence over here. Okay, so what is the clinical interpretation? A prevalence of 20% means 20% of the population is currently having the disease. Okay, prevalence of the disease is 20%. That means 20% of the population is currently having the disease. Okay. So now next concept is the incidence. Okay. So what does incidence measures? Incidence measures the new cases occurring over a period of time. Okay. So incidence is measuring new cases which is occurring over a period of time. So suppose we have the 100 disease free women at the beginning of the study. We are following these ladies for 5 years and the 10 patients develop the disease. Then we will get the incidence as a new disease. Okay. So we had a population. We have followed up the population over a period of 5 years for disease outcome and 10 patients develop the disease. So that will give us the new cases as the incidence. Okay. Now there are two types of incidence. One is a cumulative incidence and second is the incidence rate. Okay. So first is a cumulative incidence, also called as risk. So what does the cumulative incidence means? Cumulative incidence equal to new cases during the follow-up divided by the population at risk at the start. Okay. So it is the new cases during the follow-up divided by population at risk at the start. Okay. So in percentages, cumulative incidence in percentages will be new cases upon population at the risk multiplied by 100. But to calculate the cumulative incidence, there are certain conditions. Like we should have a fixed population. The population should complete the follow-up and everyone should be followed up till the study end. Then we can get the cumulative incidence. Okay. So this is not always possible, but if this is carried out, then we will get the cumulative incidence. Little difficult. Okay, we should have a fixed population and all the population should complete the follow-up and everyone should be followed up till the end. Okay, for example, 120 heart attacks among 1200 men which are followed for 10 years. Okay, then cumulative incidence will be 120 divided by 1200. So cumulative incidence will be 0.1, that is 10%. Okay, so 120 heart attacks developed over a period of 10 years among 1200 men which are followed from the beginning till the end. Then you get a cumulative incidence, that is 120 divided by 1200, that is equal to 10%. Okay, so interpretation is 10-year risk of heart attack is 10%. That is how we interpret. So 10-year risk of heart attack is 10%. Okay. Now the next is a incidence rate. So we have seen the cumulative incidence first. Okay. Now we are talking about the incidence rate. Incidence rate equal to new cases upon percent time. Okay. So here the denominator is a percent time. This is the new measurement. That is it is measured with the percent time. Okay. So when it is used, when there is a loss to follow up, deaths from the other causes and variable follow-up period is there, because these are the practical situations which are going to happen, because you have the population at the start, but all the population may not last till the end of the study. They may lose the follow-up, there may be death. Okay, and you may have a variable follow-up period. So in this particular case, the incidence rate will be useful. Okay, so the concept of percent time is used here. Okay, so incidence rate uses the concept of percent time. That means a participant A is followed for 5 years, participant B is followed for 3 years, participant C is followed for 2 years. Then the total percent time will become 5 plus 3 plus 2. That is equal to 10% years. Okay, so this is the percent time concept. Okay, and this is useful when there is a loss to follow or death from other causes or variable follow-up period. Okay, so for example, if you have got 100 deaths, you know, 15,050 person years. Okay, so 100 deaths in 15,050 person years. So you will get an incidence rate as 100 divided by 15,015, that is equal to 0.00664 person year. Okay, per person year, that is equal to per 1,000 year it will be 6.64 per 1,000 person years. Okay, so incidence rate is calculated per person year. Okay, so there is a difference between the cumulative incidence and the incidence rate. So cumulative incidence is also called as a risk, while incidence rate is called as incidence density. Okay, so cumulative incidence is also called as risk, while incidence rate is called as incidence density. Both are in both the numerator is same, that is new cases. Both cases numerator is same, that is new cases, while denominator is different. In cumulative incidence, denominator is a population at risk at the start of the study. Okay, while here, this is a reminder. Alexa, stop. So in both cases, denominator is different. Denominator in cumulative incidence is a population at risk at the start, while in incidence it is a percentile. Okay, unit is a proportion or percentages for cumulative incidence, and for incidence rate it is cases per percentile. Okay, now what cumulative incidence answers? Cumulative incidence answers the probability of the disease, while incidence rate gives us the speed of the disease occurrence. Okay, so follow-up is same for all in cumulative incidence. Follow-up can vary in the incidence rate. Okay, now we'll see prevalence versus incidence. What we saw, cumulative incidence versus incidence, the incidence rate. These are the two types of incidence, and now we will compare the prevalence versus incidence. Okay, so prevalence deals with the existing cases, while incidence deals with the new cases. Okay, now the time element is pertaining to the incidence. It is not pertaining to the prevalence, because we are calculating incidence over a period of time. Okay, so time element is pertaining to the incidence. Cross-sectional study will give prevalence. Okay, cohort study will give you incidence. These are the frequently asked SBS. Cross-sectional study will give you prevalence. Incidence you will get in the cohort study. Okay, measures burden. Who measures the burden? Prevalence talks about the burden of the disease, while incidence talks about the risk. Okay, so this is what is the very important concept, prevalence versus incidence. You should revise this particular concept. Okay, so prevalence is actually a photograph or the snapshot, while incidence is actually taken a video over a period of time. So there is a follow-up over a period of time. Okay, so that is what is the, just for the understanding purpose. Okay, now there are measures of association. Okay, so measures of association, the purpose is to compare the disease frequency between the exposed group and the unexposed group. Okay, now we will consider R1 is the risk in the exposed and R0 is the risk in the unexposed. Okay, now we have already seen the 2 by 2 table. Disease was on the top and risk was on the side. Okay, so risk in the exposed and is denoted as R1. Risk in the unexposed is denoted as R0. Okay, then we have two measurements. Okay, two measurements here. One measurement is a risk difference. Okay, so risk difference equal to risk in the exposed minus risk in the unexposed. Okay, so we have got a exposed group, we have got an unexposed group. So risk in the exposed minus risk in the unexposed is the risk difference. So RD equal to R1 minus R0, exposed minus unexposed. Okay, where R1 is the risk in the exposed, R0 is the risk in the unexposed group. So interpretation is the absolute increase in the risk due to the exposure. So this much is the increased risk because of the exposure, because there is going to be a baseline risk otherwise also for both the groups. So here we are calculating the risk which is exclusively due to the risk factor. So absolute increase in the risk due to the exposure is denoted by the risk difference. Okay, now the next measure is a relative risk, and this is very frequently asked. Okay, so the formula for the relative risk is risk in the exposed divided by risk in the unexposed group. Okay, so the formula is risk in the exposed group divided by the risk in the unexposed group. So RR equal to R1 upon R0. Okay, so it is a risk in the exposed divided by risk in the unexposed, that will give you the relative risk. Now, how we interpret? If relative risk is equal to 1, that means there is no association. Both group have the same risk, which has not such a meaning. Okay. So the baseline risk itself is same for both. So the risk factor related risk is not there. Okay. So RR equal to 1, that means there is no association. If RR is more than 1, that means it is a harmful exposure. If RR is less than 1, that means it is a protective exposure. There may be some intervention which is protecting against certain disease. So that is that will, in that particular case, relative risk will be less than 1. Okay. So in smoking and lung cancer, relative risk will come as a more than 1. Okay. So risk in smokers is a 40%. Risk in the non-smoker is a 20%. So relative risk will be 20%. Sorry, 40% divided by 20%, or 0.4 divided by 0.2 equal to 2. Okay. So interpretation is smokers have twice the risk. Okay. So that is how the relative risk is calculated. Okay. So these concepts are, and another third concept which is frequently asked in the examination is the odds ratio. Okay. So for what is the formula for the odds ratio? It is AD divided by BC. Okay. So what we have seen, A, B, C, and D, that we have seen in the table. Okay. So AD divided by BC will give you the odds ratio. Another formula for the odds ratio is R1 divided by 1 minus R1 and the whole divided by R0 divided by 1 minus R0. Okay. But AD upon BC you remember. But while calculating this AD and AD upon BC, remember the disease is on the top and the exposure is on the side. And here disease present, disease absent, exposure present, exposure absent. Then you give A, B, C, D. Okay, if you mark it wrong, then your these calculations will go wrong. Okay, so what is the interpretation? Okay, if odds ratio is 1, that means there is no association. Okay, now if the odds ratio is more than 1, that means there is a positive association. If the odds is less than 1, that means there is a protective effect. Okay. So odds ratio is very favorite for the examination. Okay. So odds ratio is used in the case control studies. Remember, there are certain things which we have seen. Okay. Prevalence, cross-sectional study. Odds ratio, case control study. Okay. So whenever there is going to be odds ratio, always remember case control study. So this case control study cannot calculate the incidence. Incidence will be calculated by the cohort study. Okay. So case control study will give you the odds ratio. Then case control study cannot calculate the relative risk also. Both these incidence as well as the relative risk will be calculated in the cohort study. Therefore, we use odds ratio in the case control study. Okay. So cohort study will give you the relative risk as well as odds ratio. RCT, randomized control trial, will also give you relative risk and odds ratio. But case control study will give you only odds ratio. Okay. Okay. So this you have to remember about the odds ratio. It is related to the case control study. Okay. Now the study design and the measurement, the same thing very frequently asked. Cohort will give you the relative risk. It will also give you the incidence. Okay. Then RCT will give you the relative risk. Case control study will give you the odds ratio. Cross sectional will give you the prevalence ratio. Okay. From SBA point of view, you should remember when there is a question stem mentioning existing disease burden, that means we are dealing with prevalence. If we are talking about new disease development, that means we are dealing with incidence. If we are comparing the risk between the two groups, that means we are talking about the relative risk. The risk is compared between the two groups, that means we are talking about the relative risk. Okay. Case control study will give you the odds ratio. Absolute effect of exposure is the risk difference. Okay. Absolute effect of exposure is the risk difference. That is R1 minus R0 that we have seen. Okay. Then loss to follow-up is present. Okay. That is incidence rate. Okay. So these are the things which you should remember. So suppose your question mentions current number of women with gestational diabetes. What does it indicate? Current number of women with gestational diabetes. What does this mean? We are talking about
Prevalence. Prevalence of
Prevalence.
gestational.
Yes, yes. If the question is talking about women are followed for 10 years, that means we are dealing with,
Incidence.
yeah, because time element has come. Okay. Then question is talking about case control study. Then what we are going to get as a in the result, case control study will give us
Odds ratio.
odds ratio. Okay, it will never give the relative risk. Okay, suppose your question mentions about the risk is doubled. What does it mean? Risk is doubled. Risk is doubled in this particular group. As yes, it is relative risk. RR is 2. Okay. If your question mentions there is no association, then what you can conclude? There is no association. What does it mean?
RR is
RR is,
1.
RR is 1 or odds ratio is also 1.
Odds
Okay.
ratio is 0. 1.
No, no, or ratio will be 1. Ratio will be 1. Okay.
1.
Yes. Okay. Ratio will always be 1. Okay. So this is the snapshot or one page summary. Proportion is a part of the whole population or a whole sample, and what it gives is a frequency. Okay. Odds is a part of a non-part. Okay. Two things we are just putting one upon the other. So that is calculated in the case control study. Okay. Then prevalence is the existing cases divided by the population. That tells about the disease burden. Cumulative incidence is the new cases divided by population at risk, and it another name is a risk. It gives us the risk. Okay, cumulative incidence will talk about the risk. Then another type of incidence is the incidence rate. That is the new cases per person time. Okay, that is a variable follow. Okay, because there is a variable follow, we get the incidence rate as a person time. Okay, risk difference is a R1 minus R0. That is the absolute effect we are going to get because of the exposure. Relative risk is R1 upon R0 that you get in a control cohort or the RCT. Odds ratio is AD upon BC that you get in the case control study. Okay. So for memorization, you remember this pyro rule. Okay. P is a prevalence, that is present cases. I is incidence, that is the incoming or new cases. R is a relative risk, that is the risk comparison. Odds O for odds ratio, that is the odds comparison, especially in the case control study. Okay. So this is the same thing we have seen. Existing cases is about prevalence. New cases will give us the incidence. Follow-up over a period of time, again incidence. Complete follow-up is the cumulative incidence. Okay. Person year is the incidence rate. Cohort study will give us relative risk. Case control study will give us odds ratio. RR equal to 1, that means there is no association. RR more than 1, that is the harmful exposure. RR less than 1, that is the protective exposure. Odds ratio will be given by the formula AD upon BC. That is very frequently asked in the examination. Risk difference is the absolute effect and relative risk is the relative effect. Okay. So that finishes the today's topic of incidence, prevalence, relative risk and odds ratio. We have certain questions, Doctor. Dr. Monica, you want to start these questions?
Yes, sir. Question number 1. A cross-sectional survey of 5,000 women attending primary care clinic found that 500 women currently had urinary incontinence. What is the prevalence of urinary incontinence? A 0.1, 0.01, B 0.05, C 0.10, D 0.20, and E is 0.50. Sir, so this is
Calculate. What is there in the numerator? What will be in the denominator? Prevalence they are telling.
500 will be in numerator and 5,000 in
Yes, 500
denominator.
divided by
Answer will be
5,000. That point, no, it will be 0.1. No, 0.1.
0.1. Yes, sir.
0.1. Okay. So please be very careful about pointer in the examination. Okay. 500 divided by 5,000, it will be 0.1 or 10%. Okay. So prevalence measures existing disease burden at a point in time. Okay.
Yes.
Next.
Question number 2. A cohort of 2,000 women free from the osteoporosis was followed for 10 years. During the follow-up, 100 women developed osteoporosis. What is the cumulative incidence? A is 0.005, B is 0.05, C is 0.10, D is 0.20, E is 0.50.
So numerator, denominator, L.
100 divided by 2000.
2000. Okay, so it will come as a 0.05. Okay, it will come as a 0.05. Okay, so cumulative
0.05.
incidence is a new cases divided by
New cases
population at
among
risk.
population at
Okay,
risk
new
at the
cases were
start
100
of the
divided
study.
by 2000. Okay, that is around 5%.
Yes.
So incidence measures new cases developing over a period of time. Next.
Question number 3. Which epidemiological measures is the most useful for estimating healthcare resources required for women currently living with rheumatoid arthritis? A. Relative risk, B. Incidence rate, C. Odds ratio, D. Prevalence, and E is the risk difference.
So you are going to give healthcare related resources, no? So what should be the most important you should know about the population? You want to know the
Uh, Sir, is it uh, relative risk?
currently living with the rheumatoid arthritis. Women currently living with the rheumatoid arthritis. Currently living. What does it mean?
That is prevalence.
Yes, because you want to know the how much is the burden because you are planning the resources. No, if you know
Okay.
the disease burden, then you can plan the resources. So prevalence
Yes.
and the other keyword which I told you is the currently living with the rheumatoid arthritis. That means we are talking about the disease burden. Okay. So prevalence
Yes.
is the existing cases divided by total population. Prevalence measures the total burden of the disease currently present in the population and is therefore useful for planning services, allocating resources, estimating treatment needs. See, this is how the question is twisted. Okay, we understand the concept, but we should be able to, apply this concept in the scenario. Next.
Question number 4. A cohort study reports breast cancer with HRT user is 120. No breast cancer with HRT user is 880. Breast cancer with non-HRT user is 60. And no number of breast cancer with non-HRT user is 940. What is the relative risk? It is 0.5, B 1, C 1.5, D 2, and E is 3.
So how we are going to calculate the breast cancer develop 120 in the HRT users and no breast cancer 880. So total HRT users are 1000 and total
120,
non-HRT
1000.
users are also 1000. 60 plus
1000.
940. So 120 divided by 1000 divided by 60 divided by 1000. Okay. So 1000 1000
Yes,
will
sir.
go. Okay. Then 120 divided by 60 will remain. So that will
60.
become a 2.
2.
Okay. You
Yes, sir.
got it.
Yes, yes, sir.
So women with HRT have twice the risk of the breast cancer. So this type of calculations will come in the examination and it is a sort of data interpretation also. Okay, they may give this and they will ask you the interpretation. What does it mean? Okay, next.
Okay, sir. A study reports the relative risk of 1. What is the most appropriate interpretation? Exposure is protective. Exposure double risk. No association exists. Odds are double. Exposure half risk. So answer is C. No association exists.
Yeah, because RR is equal to 1. Okay,
1.
R1 upon R0, that is RR equal to 1 means risk among exposed is equal to risk among the unexposed. Therefore, no association between the exposure and the disease. Okay. RR more than 1, harmful exposure. RR less than 1, protective exposure. Next.
Odds ratio from 2 by 2 table. Cervical cancer and HPV positive negative. Cervical cancer with HPV positive is 80. Cervical cancer with HPV negative are 40. No cervical cancer with HPV positive is 20. No cervical cancer with HPV negative is 16. What is the odds ratio?
Odds ratio formula?
AD upon BC.
AD upon BC. 80 into 16 divided by 20 into 40. Okay.
40.
So AD upon BC we are going to calculate. That will come as a 6. Okay. 80 into 60 divided by 20 into 40. Okay. 4800 divided by 800, that will give us 6. So HPV positive women have 6 times the odd of cervical cancer. Okay. Next.
Yes, sir. Question number 7. Which measure of association is the most appropriate for case control study? A relative risk, A risk difference, B relative risk, C incidence rate, D odds ratio, and E is prevalence ratio. So it's odds ratio for case control.
Case control, odds ratio. Where do you get prevalence? In which study you will get prevalence? Prevalence?
Prevalence in cross-sectional study.
Correct. Cross-sectional prevalence. Incidence? Cohort.
Cohort.
Okay.
Yes, sir.
So odds ratio equal to AD upon BC. Case control study will give you the odds ratio. In case control study, incidence cannot be calculated. Relative risk cannot be calculated directly. Odds ratio is used for end of the study. Next.
Yes. In study, there are 300 females and 700 males. What are the odds of being female? A 0.30, B 0.43, C 0.50, D 0.70, E 3.00. So odds of being female is 300 upon
700. It
1000.
will be B 0.43, no?
D.
Suppose if it's 300 and 600, that will be 0.5. Okay, if it is 700, if
Yes,
this is 350, that means it will be 0.5. But this is not 350, this is 300 only. So less than 0.5, less than 0.5, only one answer, 0.43. So you don't have to calculate also. If 0.3, then this should have been 900, no? 3 times of this,
yes,
approximately. So just look at the figures. Okay. So it will be 0.43. Odds equal to part upon non-part. Okay. Odds equal to number of with characteristic divided by number without characteristic. Okay. Next.
A researcher wishes to determine how quickly new
please,
cases
here
of...
they have given, just do not confuse with the proportion. Proportion is a 300 divided by 1000, that is 0.3. Okay, so it is not a proportion among the whole. Okay, so because there were 300 females and 700 males, that means total population was 1000. Okay, so otherwise proportion will be 300 divided by 1000. Okay,
1000
for females, 700 divided by 1000 will be proportion for males, but we are talking about the odds. Okay, so that is what is another thing which you should remember. Okay, so we are talking about the odds and not for the proportion. Yeah, next.
Question number 12. A researcher wishes to determine how quickly new cases of endometrial cancer are occurring in the population. Which measures the most appropriate? A prevalence, B median, C odds, D incidence, and E proportion. New cases, sir, it is incidence.
Yes, we are talking about new cases, that means incidence. So incidence equal to new cases divided by population at risk. Incidence equal to new cases during the follow-up divided by population at risk. The phrase how quickly new cases occur immediately indicates the incidence. Next.
A study report RR is equal to 0.4, which interpretation is correct. A, there is no association. B, exposure increases the risk. C, exposure doubles the risk. D, exposure is protective. And E, disease causes exposure. Sir, it is protective.
Yeah,
Or
RR is less
exposure
than
is
1, so it
protective.
is protective. Okay, less
Protective.
than 1 indicates reduced risk among the exposed individuals. A value of 0.4 suggests a 60% reduction in the risk, relative risk equal to R1 upon R0. Okay, next.
Which study design most commonly provides prevalence data? A randomized trial, B cohort study, C cross-sectional study, D case control study, E ecological study. So cross-sectional study.
Yeah, prevalence
C
cross-sectional
cross-sectional
study.
study.
Okay, so
Yes.
cross-sectional studies provide a snapshot of the disease status at one point of time. Therefore, they measure the prevalence. Next.
A case control study investigated smoking and ectopic pregnancy. Which measure should be reported? A incidence, B relative risk, C risk difference, D odds ratio, and C cumulative difference. So it is odds ratio.
Because we are talking about the case control study. So case control study will
Yes.
give you odds ratio only. Okay,
Odds
AD
ratio.
upon BC is the formula. Cohort study will give you the relative risk. RCT will also give you relative risk. Case study will give you odds ratio. Cross sectional study will give you the prevalence. Okay, so from examination point of view, same cohort relative risk, RCT relative risk, case control odds ratio, cross sectional prevalence. So this is, since this is a cross sectional study, the correct answer is odds ratio. Okay, so that finishes the today's topic of incidence, prevalence, odds ratio, relative risk, etc.